walk through it quickly though. Okay, so these are going to be our definitions for limits. We already know that if we're looking for the limit as x approaches some number, it only exists as long as it's approaching the same value from the left side as from the right side. So that means we can find one-sided limits, and the way we know that is after the number you see what? Either a little negative sign. Yeah, either a little negative sign like that or a little positive sign. And that will show you which way you're coming from, and that's a one-sided limit. Now, the properties, there's a couple of them we haven't really talked about, but they're very important, so I want to make sure that this makes sense to you. The K here on number 1 stands for a constant. It's just a number. So if I am looking for the limit as x approaches 1,000 for 2, okay, basically what that's saying is my graph is y equals 2. Does it matter where I am for my x value? Do I know what y is always going to be? It is. It will be 2. So if you're taking the limit of a constant, the limit will always be that constant because it is just a horizontal line. Every y value on that line is going to be the same. Okay? Excuse me. If you're taking the limit as x approaches some value and your function is just x, remember that's the line y equals x. So whatever value you're approaching, your x and your y have to be the same, okay? So those are going to be 2 pretty quick and easy limit rules to use. The rest of these we talked about a moment ago, that you can add limits, you can subtract limits. If you have a constant that is being multiplied times a function, if you get the limit of the function, multiply it times the constant. If you have a product of functions, you can get the limit of each of the functions and then multiply those limits. That's number 6. Number 7 is the same as far as a quotient. You can find the limit of the top function and the limit of the denominator, and your limit would be their ratio as long as the denominator does not equal 0. Remember, that's important. And, excuse me, as long as you have a radical, it says that as long as the root is even, if you have an even root or an even index, then you can take the limit of that. So let's look and make sure we can read these graphs. Okay? We're going to look at the graph to see if we can evaluate these real quickly. What do you think on A, the limit of this function is as x approaches 1 from which direction? That's going to be from the right because of the plus sign. And what will be our y value? As I'm moving closer and closer to an x value of 1, look at the graph. The graph is right here. Okay, as I'm moving closer and closer to 1, what is that y value? 1. It's 1. That's it. Okay, doesn't matter that there's an open circle there. Remember, finding the limit is not the same thing as evaluating at that point. As long as it's continuous, they will be the same. But remember, sometimes we have these open circles and different things, and so we're just looking to see as we're moving toward that value, what are we approaching? All right, look at B. What if we approach 1 from the left? What's going to be our limit there? So that means start on this side of the graph. As I'm getting closer and closer to a value of 1, what is my y approaching? 2. It sure is. Is this making sense? All right, look at C. What would you tell me is the limit of this function as x approaches 1? Remember, it's got to be the same thing coming from the left side and the right side. Is this the same thing coming from the left and the right? Coming from the right, the limit was 1. Coming from the left, the limit was 2. That means this does not exist because it's not coming toward the same number from both the left side and the right. Now, notice what D is. Do you see limit written anywhere? No, it's only asking you what's the value of the function when x is 1. So look at your graph. Where is the closed circle when x is 1? Y is what value? That's it. Make sense? All right, let's try the next one. Let's look at 3 now, an x value of 3. On on E, it's coming from the right side of 3. Coming from the right side of 3, what is that limit? The y value is getting closer and closer to what? Yeah, if I'm coming from the right side, I'm getting closer and closer to a y value of 1. Correct? All right, now what about as I'm approaching 3 from the left? It's also 1, isn't it? So what would be the limit as x approaches 3? It only exists if it's approaching the same number from both the left side and the right, is it? So what's the limit? Oh, come on. What number is that? It's 1, isn't it? As long as it's approaching the same number from the left as it is from the right, then the limit exists as x approaches 3. And what is f of 3? Is there some value on the graph that exists when x is 3? What do you think? You see any closed circles at 3? Only an open circle. That means f of 3 does not exist. All right, so you're getting the difference between when you're finding the limit and when you're looking for the value. Got to make sure you understand those. Okay, so look at A under number 2. Evaluate the following limits. Can you find the limit as x approaches 2 for this function? What would we try to do? Plug in. So if I try to plug in, I'm going to get 2 minus 5 on top over 2 minus 2 on bottom. Well, what does that equal? That's a negative 3 on top over what on bottom? Now, if it's negative 3 on top, 0 on bottom, what do I know about the limit? Does not exist. Very good. If it was a 0 over 0, that's indeterminate. It tells me maybe I could factor or do something else and find it. But as long as 0's on the bottom and a different number's on top, the limit does not exist. Now, look at B. We want to find the limit as x approaches negative 4. Let's see what you guys come up with on that. All right, what is this? When you plugged in negative 4 in the numerator, what did it give you? It gave you a 16 minus 16, which is 0, over my denominator was a negative 4 minus 3, which is a negative 7. What does that mean? My limit is, what does 0 on top of a fraction mean?
0.
Exactly. 0. When 0's in the denominator, it's undefined, and the limit doesn't exist. But if 0's in the numerator and you have a number that's not 0 in the denominator, then the limit is 0. Now, on this last one, plug it in, see what you get. So what happened when you tried to plug in 2? I got 0 on the top. What did I get on the bottom?
0.
Oh. If it's 0 over 0, that means it's indeterminate, right? Which means I need to look for another way to find it. So what would I try to do? factor. Look at that numerator, x squared plus 3x minus 10. Is there a pair of numbers you could multiply to get negative 10, add to get positive 3? Sure can. This should factor into x plus 5 times x minus 2. Okay, and you could go through all the steps of factoring to get there, but this is what you should end up with, over x minus 2 in the denominator. Now, what could I do with that?
The x minus 2 on top and on both hands.
Yes, they do. And that means that I would be looking for the equivalent of finding the limit of x plus 5 as x approaches 2. And now I can sub in directly. What would that be? 7. You're exactly right. Okay? Then let's look at a couple more. All right. We have on number 9, something that's quadratic on top. For the first part of our piecewise rule, the second part is linear, and we're supposed to find the limit of f of x as x approaches 1 from which direction? From the left. So, see if you can tell me how we do that. If I'm approaching 1 from the left, I've got to figure out which one I plug into. If x is less than 1, that's going to be coming from the left, right? So I plug into the top one. Would you agree? Okay. If it's a one-sided limit and the value they've given you is in the domain restriction, then you're only going to be plugging into one or the other. You won't be plugging into both. So on this one, I would plug in, as x approaches 1 from the left, means that I'm plugging into x squared plus 2. So if I put in 1, square it, add 2, I get what? 3. That's my one-sided limit coming from the left. Now, what's it asking me to do on the next one? Come from the right. So you guys would need to do what? Plug it into the second function, because the second function is what you use if x is greater than or equal to 1. So greater than or equal to means we'd be coming from the right side. So I'm going to plug into 4x minus 1. And when I do that, 4 times 1 minus 1 is how much? So tell me, does the limit exist as x approaches 1? Because it's the same number from both directions. And if I were to ask you why this is true, why would you tell me? What's the rule? The limit as x approaches some number exists as long as what? That is exactly right. The limit as x approaches 1 from the left of our function is equal to the same thing as the limit when x approaches 1 from the right of our function. That's why the limit exists. Okay, look at the next one. We've got another piecewise function. And 2 is in our domain restriction. So on A, we're supposed to find the limit as x approaches 2 from the left. On B, we're going to find the limit as x approaches 2 from the right. I want you guys to take a second and do that. Okay, I don't think we're having a lot of difficulty with this. On the first one, if I'm approaching 2 from the left, did that mean you plugged into the top or from the bottom? Into the top function. So we plugged into 5x minus 6, and that meant you had 5 times 2 minus 6, which was how much? 4. That meant On the next one, because you were approaching 2 from the right, you plugged into the bottom function, which gave you what? 8 as a value. Now, if you have to answer the question, what's the limit as x approaches 2, what would you say? Does not exist. Now, can you answer the question, what's the value f of 2? How would we do that? What would we have to look at? We'd need to go back and look at the domain restriction. Which one of those had the or equal to? The top one. And so if I plug 2 into that top equation, I got what? 4. That's what f of 2 is. That's the value that exists when x is 2. And remember, anytime I'm taking the limit, I'm looking for what's the value y is approaching. If I'm evaluating the function, I'm looking for the value that y is for that particular x value. Okay, one more example and then we'll be done with this section. We have a rational function here, and the first thing we're supposed to find is the limit as x approaches 1. Now, here's what I want you to notice real quickly. Can you tell if we're going to have a problem subbing in directly with 1? Brittany says yes, and I agree with her, because what's going to happen in the denominator? It's going to be a 0. And if I did a quick check, I would see I'd also get 0 in the top. This thing would be indeterminate. So what should I try to do? Let's see if we can factor the numerator. Fortunately, my a value is 1, so I'm trying to think, is there a pair of numbers I could multiply to get -5, add to get +4? Because our a times c is 1 times -5, which is a -5. And the b value is a +4. If I multiply 2 numbers and I get a negative, what do I know about signs? I know that one's positive and one's negative, and you said if we use a +5 and a -1, that should be the right pair. This thing would, if we use FOIL and we double check, it gives us the same thing, right? Over x minus 1, this is what we're going to try to find the limit of as x approaches 1. How did factoring help us out? What can we do? Yes, the x minus 1s can cancel. Now I can sub in directly, and when we sub in directly is when we drop writing limit. And if I put 1 in for x, what do I get back? Exactly. 1 plus 5 is 6. So the limit as x approaches 1 is 6. Now, let's see if you can figure out what would be the limit as x approaches -1. Would we have any problem subbing in directly here? I don't think so. Let's see what happens. So if we were going to sub in directly, inside this parentheses, I'd have -1, square it, plus 4 times -1 minus 5 on top, over -1 minus 1 on bottom. Clean that up for me. And then tell me, did you end up with a fraction answer, or did you get a whole number value? Was it positive or was it negative? Positive, because if I clean up the numerator, did you come up with a -8? Over the denominator is a -2. That is equal to a +4, right? Okay, and then on the last one, if we were to plug in -5, again, it's not going to be indeterminate because the denominator is not going to be 0. So what I need to see is what happens if -5 goes in for x. And what did you get back for that numerator? When I square -5, that's a +25. 4 times -5 is a -20. And then I have a -5. What's that numerator? 0. And 0 divided by some number that's not 0 is what? What's my answer? What's 0 over negative 6?
0.
0.